Hi friends, good morning to everyone. We have solved some problems right using functions in the last session. Have any queries? If you have any queries right in the topic right, you can ask now. Otherwise, we will move on to a new topic. Okay, in this session right now we like to focus on inline functions. Inline functions are right functions which are expanded in line. Functions which are expanded in line. The sense that whenever the function definition is small, for small functions, how can you say a function is small or large? Based on the number of lines, right? Lines are four, LOC. For small functions, we can define as inline functions. For that, what we have to do, we need to use the keyword inline. Inline, this is the keyword to be used. Normally, right, we can define a function using the general form, return type, function name, parameter, list, then opening and closing a curly braces. In case of inline functions, we need to define the function before the main function itself. How to define inline functions? Use the keyword inline, then define the function as it is. That means inline, this is preceded by the keyword inline, right? This is the keyword preceded by the normal function definition. Inline, what is a normal function definition? Return type, function name, parameter list, opening and closing curly braces. Here, this is the place to define the function statements or simply function definition. The advantage is we can call the function right in the short amount of time. So function call right cost has been reduced. Function call cost right, that means time. This is reduced when the functions are defined as inline functions. You have right studying or you have studied right the computer architecture paper. There right we are going to use different kinds of registers. So the functions are right going to be right stored right in the register locations. That stage right accessing the function will be a faster one. So for small commonly used functions, the time needed to make the function call is often a lot more than the time needed to actually execute the functions too. So this kind of overhead occurs for small functions because execution time of small function is less than the actual switching time. So to resolve this issue, to reduce the function call overhead, inline function, that is a special function that we can say the function is expanded inline when it is called. When the inline function is called, whole of the inline function gets inserted or substituted at the point of inline function call. So just think of in the normal functions, suppose we are in a main function, we are calling right function f1, control is transferred back to the function, right, or control is simply transferred to a function called f1. Actual parameters are pushed onto the stack. F1 gets executed, right? After the complete execution of F1, return address, right? Stack pointer returns, right, to the calling place. So control comes back again to the main method, main function. Assuming that a function F2 is called another function, then control is transferred from the main function to right the function F2. After the complete execution of F2, control is returned back to the main function, right? So that is the normal function call scenarios. But whenever we use the inline functions, the functions are expanded inline, right? When they are called, that means when the inline functions are called, the whole part of the inline function, that is whole statements of or whole function definition of the inline functions are getting inserted or substituted at the point of inline function call. So simply the functions are right called from the function definition to the main function, right? There will not be a function call right from main function to the inline function. Hope you understand. Function definitions are right simply right replaced to the calling place. So what is the advantage? The function call cost is simply reduced. So the substitution is performed by whom? That is the question. C++ compiler is responsible during the compile time for finding this or for implementing this substitution process. Inline function may increase the efficiency if it is small. So the syntax is inline, return type, function name, parameter list, opening and closing curly braces. Within the opening and closing curly braces, define the task of smaller functions. That is the advantage. Inlining is only just a request to the compiler. This is not a command. Compiler can ignore the request for inlining. Compiler may not perform inlining in certain situations. If a function contains a loop, for example, the restrictions are say for, while, do while, and a function contains this kind of control concepts, right? Compiler right may not perform inlining operations, right? That depends upon the compiler being used. Likewise, when a program, right, or function contains static variables, right, inline functions will not work. When a function contains static variables, yes, right, we see later, right, when we discuss objects and classes, we explore, right, what is a static variable. Another one is when an inline function is recursive. Recursion, right, a function can call itself. That is a recursion. When a function is defined as a recursion, inline functions will not work. If a function return type is other than the void and the return statement does not exist in a function body, inline functions will not work. If a function right contains a switch or go to statement, these are some restrictions. Switch, go to statements, and these are a part of right function definition, inline functions will not work. So what are the advantages of inline functions? First advantage, right, this one. Function call overhead does not occur. That means the computational time is saved. It also saves the overhead of push pop variables on the stack when the function is called. That's what I have said earlier. When the function is called, the actual parameters are pushed onto the stack. Then after the function call, the stack pointer, right, then it gets executed, then the corresponding return address, right, will help to return the control to the calling place, say main function. So that is the push pop operations in the normal function call. So these push pop operations are completely eliminated. So the function saves the overhead of a return call from a function. After the function gets executed, return statement, right, returns a value to somewhere, right, the calling place. So there should be a stack pointer, right, pointing the return address. Unnecessarily, right, a return address need not be pushed onto the stack. Then it need not be, right, popped from the stack. Push pop operations, right, are completely eliminated. So it saves the function call overhead. When you inline a function, you may enable the compiler to perform the context-specific optimization and the body of the functions. So that can be defined using this general form. Inline functions, right, may be useful only for smaller functions because the functions are, right, just replaced or substituted to the calling a place. Even there are certain disadvantages, right? Having right functions with for, while, do while, static variables, recursion, switch, go to, right? In these situations, inline functions will not work. Now let us see one example how inline functions are defined. Inline functions can be defined like a normal function definition, or later, right, we will focus on classes and objects. That stage also we can perform or we can make the function as inline function with respect to objects and the classes. So as of now, we are going to define a smaller function as inline functions. Take this example. Yes, these are the restrictions. Restrictions where inline function may not work for some compilers. For while, do while. So now let us define the inline function. Define the determinant of a quadratic equation. So how to define? Include the header files, hash, include iostream.h. Then before the main function, define the inline function. So there is no right function prototype. As we have discussed earlier, when the functions are defined before the main function, no function prototype is required. Simply right, the function is placed just before the main function. So when control right comes right in the sequential execution of main, when the function is called, the compiler knows that right the function has already been defined before the main function, so there will be no issues. The problem rises, right, only when the function is defined after the main function, right? If you call the function first time, or if you call the function simply, right, compiler will not know that, right, what is actually the function. So that stage, the compiler requires some prerequisite, that is a declaration. That declaration, right, may be given before the main function or even at the beginning of the main function. That is also possible. Even in the examples, right, in the last class, right, we have discussed it. The function prototype, for example, f1, when f1 is defined after the main function, we have defined before the main, right, f1 parameter is decoded. That declaration, right, may also be given, right, inside the main, right, inside the main opening curly brace. Try to give it, right, f, right, parenthesis opening and closing parenthesis semicolon. After that only, right, you are going to call the function. So you are informing to the compiler, right, the function is declared before the function is going to be called. That is function prototype. In case of inline functions, there is no function prototype. So simply define the function. For example, inline, we like to return the determinant value float. Return type is float. Next, what is the function name? Find underscore determinant. The function, right, takes the parameters float A, float B, say floats, because the quadratic equation is ax square plus bx plus c is equal to 0. A, B, C, right? These are the coefficients. Coefficients are, right, for example, we are defining as a floating point quantity. As we discussed earlier, right, function definition, right, should be placed within the opening and the closing curly braces. Now, for inline functions, function definition, right, it should be small. So simply, we are returning a value. Return b square minus 4ac, b into b minus 4.0 star a star c. The determinant, right, b square minus 4ac is computed and the value is returned to the calling place. Of course, this is a return statement, right, which involves the expression computation and the values to be returned to the calling place. The return type is a floating point one. So here floating point mode is specified, right, 4.0. So you know, right, the automatic type promotions. Float A, right, no problem. Float B, no problem. Float C. In case when A, B, C are, right, integer types, this 4.0 makes, right, the integer into a floating point type. So the complete expression is type promoter to the floating point type. The rules of, right, the type promotions are same, right, as a of a C language, similar to C language. Then writing a main function into main, see out find determinant. Suppose we like to pass the values 2, 3, 1. 2, 3, 1 are actually, right, integer values. These are converted into the floating point values. Copy, ensure, see out find determinant 1, 4, 5. Return 0, semicolon. Save the file save the example 13, CEXX 13. Now let us compile the code F9. I have pressed F9. The code has been compiled successfully. Control F9. What is the result? Right, first 1, another one is minus 2. Right? Think of the the manipulator, RENDL, or new line character. File, save, control F9. First one, second one, b square minus 4ac is minus 2. The values are returned to the calling trees. Actually, here there is no function, right, or return concept here, because the function is defined as an inline function, right? So compiler, right, just replaces this function definition, right, simply to the main function. That stage, right, we cannot, right, visualize how the functions are actually going to be called, but the push pop operations, these are completely eliminated because of the substitution, right? What happens? Function call overhead, simply function call, right, time is reduced compared to the normal function calls. That is the advantage of inline functions. Having any queries? Any queries?
No, sir.
In case if you remove the keyword inline, right, what happens? F2, control F9, even you will get the same result. That's what I said, right? You cannot visualize, right, how the function call is actually taken, right? But you can, right, measure the computational time. Later, right, in the coming semesters, you will be learning algorithms paper, right? So that stage, right, you will learn how to find the actual computational time of an algorithm, right? So you can call a function, for example, 1 lakh times. You can start the timer, right, before calling the function, and after 1 lakh times has been successfully called. Then find the time difference and divide it by, right, for example, 1 lakh, so that you will get the actual time taken, right, to call for a single call, right? So likewise, right, in case, right, if you have introduced some statements, and you can measure the actual time taken, right, for the normal function calls as well as inline function calls. So the general form is, right, inline, then return type, function name, parameter list, then function definition. You can define, right, how many inline functions mean. You can define any number of inline functions. For example, inline, simply void, or you can remove void, G, out, and inside the function G, less than ENDL. So G, right, this is the inline function. Let us call the inline function here G, G. I has been saved, control F9. It seems that, right, twice the function has been called. So twice we expect the message. I am inside the function G. Here inline, right, simply no return type. It seems void. Function name is G, right? The parameter list is empty. So we are trying to call the function G, right, from the function main. For example, here, right, if we try to call G, control F9, errors, call to undefined function G in function. So what is the error message, right, when the inline functions are called here? First, right, find determinant is executed. That stage, right, if you are calling G, right, actually G is not known to the compiler. So you try to, right, pre-declare it. as G here. This is a solution to uh, remove the compile time error. Now control F9, I press. Twice find determinant is called. So when find determinant is called, right, just to think of during the substitution process. Initially, right, the function G has been called, so twice you can find, right, I am inside G, here I am inside G. Then the function G has been called twice, so we can find, right, last two lines. I am inside G. What is the conclusion? Inline functions can call another inline functions, right? There is no restriction because inline function is a function. One function can call another function. Using that rule, we are calling one inline function from another inline function. That is possible. But the normal rule is when you call the functions or when you substitute the functions, right, using inline, what happens? The compiler should be informed, right, earlier, right, what the function has actually been or where the function has been defined. So the compiler, right, should be informed at the beginning of the program, right, to indicate the function G is defined, right, somewhere in the program. So return type, function name, parameter list, semicolon, that should be defined at the top of the program, right, better way to remove the compile time error. That's all about inline functions, right? In case, right, they can ask questions, right? Write an inline function to perform this arithmetic, for example, having two rational numbers, P1 by Q1 and P2 by Q2. They can ask you, right, to find the arithmetic, right? Sum of two rational numbers, P1 by Q1 plus P2 by Q2. So take an LCM Q1, Q2, right, cross multiply, simplify the fractions, right, directly write it in a simple return statement, return, say P1 into Q2 plus P2 into Q1, division Q1 star Q2, that's all. Two fractions, right, are simply, right, added. Likewise, subtraction between, right, to two, right, to fractions, P1 by Q1 minus P2 by Q2, or multiplication, division, like that, right, smaller executable statements can be placed, right, as a part of the function definition with the help of inline functions, so that the function call, right, cost will get right reduced. That is the advantage. Next, right, we are moving on to the another one, right, called default arguments. File new default arguments in C++, because this is the concept, right, supported in C++ language, not in the C language, right? A default arguments, right, parameters of the term implies, right, arguments are parameters. Default arguments can be set only for functions. For example, here, I think 29 of you are attending the classes. The class strength is 43. So every day, right, it seems that some of you are, right, absent, right? Those are, right, fixed absentees. So we can, right, find out, right, if there are, right, 6 fixed absentees, or there are some 10 fixed absentees during every session. So in case, right, if I like to mark the attendance, for example, I am watching, right, the Google Classroom, right, screen. So it seems that, right, 29 of you, right, your faces, right, and the images are showing here. So using this, right, if I want to mark the actual attendance, so what I have to do, I need to check, right, every one of you individually, and then I have to mark. In case, right, if I have some right assumption, right, conclusion that every 10 members are for some 10 students, right, they are regular absentees. By default, they will not attend the sessions. So in my conclusion, right, I can mark, for example, 7 students as a default absentees. So in that stage, right, in case the strength is 7, for example, 40, then there I need to recheck, right, since the present strength is 40, I need to identify only remaining 3 students without applying the default absent is closed. So same way in C++, functions can set default values. So when the functions set default values to what, right, to the parameters, when you miss the parameters during the function call, default values will be taken. That is the logic. So from the keyword, right? It's not a keyword, right? From default, right? This is not a keyword for default arguments, but default arguments, right, can be set from right to left directions. For example, void function name is a, parameters are into x, into y, into z. If this is a function declaration, assuming that the function is defined, right, or the function is defined, right, following the main function, how will be the function call? Function call is a, three parameters should be separate, 1, comma 2, comma 3. Since there should be the exact match between, right, or there should be a one-to-one correspondence between the function call and the function definition, actual parameters and the formal parameters. Int takes into I integer, three parameters, three, right, parameters, actual parameters, 1, 2, 3. Suppose you can provide, right, in capitals, character x, character y, character z. Character can be type promoted to integer 1. That is possible. But the number of parameters and the type of parameters, right, there must be a match between actual and formal parameters. We see, right, more about that in the next topic, function overloading. So in function A, three parameters are there, three parameters must be specified in the function call. In case we consider this scenario, void same A into x into y into z is equal to say 7 declaration. In function call, we pass a 1 comma 2 comma 3. X is receiving a value 1, y receives 2, z receives 3 in this case. What is actually received in x, y, z? x1, y2, z receives 3 in the function definition. Suppose if I want to make a function call a of 1 comma 2 semicolon, in this case x receives 1, x is 1, y receives 2. The third parameter is missing. Since the third parameter has been set a default value, that is 7 in the function definition. So if you miss the third parameter, there is no issue. By default, the value of the third parameter is taken as 7. This is the logic. So just to think of where you can set default arguments. Default arguments can be set only for functions, right? So how to define the default arguments? Default arguments should be defined from right to left. This is the, for example, passing a 1 comma 2, we cannot expect to set or consider this scenario, right? Void a or void if int x is equal to 7 into y semicolon. This results in error. since right you tried to set the default argument to the left parameter and having right several parameters, you are trying to set the default argument to the left parameter. This is not acceptable. But void f into x, comma into y is equal to 7. This is acceptable. In case right, if you are passing two values, right, the two values are actually taken, missing the second parameter, right? By default, the value 7 is taken. The rule is we can define the default values to any number of parameters from right to left direction. In case I do like to define both x and y, x is equal to 10, y is equal to 25, semicolon. This is okay. In case, sorry, this is into y. In this case, right, if you miss right the values, right, for example, f. In this case, what happens? By default, x is taken as 10 and y is taken as right to 25. In case, right, f of 10, f of 12. In this case, carefully understand, we are passing one value, right? 12. So logically, x receives a value 12 and y receives a value 25 because here the count is important. You are passing one value. Here, right, two values are there. Two values are actually set default initialization. So one right, one this is taken from left to right because the rule is default initializers right should be provided from right to left direction. So when right default arguments are right useful means right, for example, in case of finding the simple interest banking applications, right? Suppose the rate of interest is say 7.5 percentage, floating point quantity, right? 7.5 percentage. When this is common for some period of time, right? We can make or you can set the parameter, right? Simple interest, right? Rate of interest parameter as the rightmost parameter in the function definition. So when you invoke right the function by setting right or by calling right explicit values, say for senior citizens, if the interest rate is 8.0, then we can specify 8.0 in the function call. So for senior citizens, right, the explicit interest rate 8.0 is assumed. Otherwise, right, if you miss the parameter, that is the rightmost parameter in this case, by default, right, the interest value, say 7.5 percentage is taken. So in these situations, right, you need to think of setting the default values from right to left direction. Let us try to check right these rules with one example. Example is right default arguments hash include IO string dot h a void f of int a comma int b comma int c is equal to 10. Then writing a main function main f of 1 comma 2 comma 3 f of 1 comma 2 return 0 void f int a Cout less than A plus B plus C equation 3.0 A and L. Let us save the file. X loading. Compiling the code are two errors. F9. Find the errors actually. Return 0. Sorry. RETURL. File save. File F9. Okay. Control F9. The average is obtained, right? In the first case, right? 1 plus 2 plus 3. The average is. The second case, right? What happens? The value, right? C is set as 10. Or if you want, right? You try to write print the value of C here. So that we can conclude. C out less than C is equal to less than C. Control F9. Sorry, control F9. F9. Control F9. A precipitate unexpectedly F8 right settings from breakpoint control F8. Okay. I write the code again. C out less than C is equal to less than C control F9. So in the first call right C has been right set as 3 because f of 1 comma 2 comma 3. The second call right by default the value C as a 10 is taken. C is 10, right? If you try to write initialize a value here, C is equal to 100, compiling the code, error message. Why is the error message? Too few parameters in call to function f of int. So in this case, right, f of 1 comma 2, this is not matched with this initializer. So this is the incorrect situation, right? So where you can provide the initializers means in case right if you remove f of 1 comma 2 comma f of 1 comma 1 comma 2 comma 1 of 1 comma 2, right? No problem. F of 1 comma 2 comma 3, right? Removing this or making command line f2 f9, no problem. Control F9 is equal to 3 because explicit value, right? C3 is taken. If you remove, right, the third parameter, there is no usage in this example because the thing is default arguments should be set in the function declaration statement. This is important. You should not define the default arguments, right, in the function definition, right, in this case. In case, right, if you check, right, the function is, right, defined before the main function, say void g int j is equal to 1000, cout less than j is equal to less than J, E and D. In this case, right, let us try to call G of 500 and G of 1001 F2 F9, no errors, control F9. Have a look into this outcome. C is equal to 3, right? Because of f of 1 comma 2 comma 3. Then f of 1 comma 2, f of 1 comma 2, what happens? F of 1 comma 2. Good. The third parameter is right here. I have updated it 500. So f of 1 comma 2, in this case, the third parameter is missing. So the third parameter is setting a default value 500. So C is 500 and find C is 500. Then have a look into right this function called g of 500. G of 500, right, even the function p is defined as a normal function before the main function. That stage in the function definition, the default arguments, right, should be set. In this case, the value, right, g of 500 means 500 is explicitly passed as a parameter to a function g, irrespective of the default value that we have set. So j is equal to 1000. This is meaningless. Actual value 500 is taken. That's what the first value of j 500 is taken. G of 1001, right? What happens? The updated value, right? 1001 has been set. So 1001 is taken. If you simply call G see what happens. We are missing the actual parameter value, but anyhow, the default value has been set in the function definition. That is, this is a function definition. I mean, not function declaration, because function has been defined here. Right? No declaration is necessary. In this case, function definition, right? The parameters specified in the function definition must or may use the default argument facility. Because of the j has been set as 1000, right? So default value 1000 is taken here. Even right, we can pass right g of 1000. In this case, what happens actually? 1000 right as the actual parameter value. So this into j is equal to 1000 is ignored. Actual 1000 from the function call statement has been taken into effect here, but anyhow, right? The result is right. You can expect 1000 control it, right? So third time j is equal to 1000. Actually, this 1000 is from the actual function parameter, right? 1000, not from the default one. 1000. So understand the rules of a default arguments. Default arguments can be set from right to left. If we have n number of parameters in the function, all of the n parameters may set a default value, right? So another one, right, we like to check as we discussed here, having right two parameters are set to default values. What will happen, right, when we pass one parameter? So define another concern, void which character ch1, character ch2. Let us set ch1 is equal to small a and ch2 is equal to small b. Cout less than ch1 is equal to ch1 less than slash t, ch2 is equal to less than ch2 dz. Okay. Now have a look into right the function call corresponding to h. H of we are passing the characters capital A, comma capital B. This is one function called H. Sorry, H. then h of small a, comma, small b, then h of S, capital S. Let us check right what happens. Close, file, save, F9, no errors. I am pressing Control F9. Have a look into this. Last three lines of outcome. Let us check it. H of A, comma B. H, what is H? H is a function defined right with the two parameters. So the two parameters are set default value ch1 is equal to a, ch2 is equal to b. Explicitly, we have passed the parameters a, comma b, capital A, capital B. So the explicit parameter values capital A, capital B are taken. Have a look into here. ch1 is equal to capital A, ch2 is equal to b. Then look on to the next line. H of a, comma b. Explicitly write, even though write a and b are set, small a, small b. Right, explicitly right, we have passed small a comma small b. So it seems right the actual parameters small a small b are taken. Then h of right yes, what is yes? This is a character. Whatever the structure of function is, that takes two parameters that are of character type. First one, right, we have one parameter that is the character one. By default, the second parameter is assigned a default value b. That means the compiler assumes that we are assuming the second parameter as a default value and you are overwriting the first parameter. So capital S is actually assigned to the first parameter. So in the last line, we can infer that ch1 is equal to S and ch2 is equal to B. Next, right, in case if we miss both parameters, right, that is another possibility. H of something, right, zero parameters. Control F9, we can find. Look into the last line. ch1 is equal to a, ch2 is equal to b, because h is a function defined with some default parameters. All parameters are defined, right, default values. So when you miss the entire parameters in the function call, automatically the default values of the parameters are taken. So ch1 is a and ch2 is equal to b. In case, right, if you define, right, another one, suppose int x, in this stage, right, what will happen? First, this results in compile time error because here you are setting the default value. You can ignore right two few parameters, but the error message is deep. What is a default value missing parameter a ch2, right? So error message is showing, right? So this means that you cannot write initialize like this. Default values, right, should be set from right to left direction or find have this function void ijk character ch is equal to q, comma, float w, assuming the dummy definition is given. File, save, F9. One error, right, corresponds to this consent declaration error. What is the error message? Default value missing following parameter ch. So how the compiler, right, intelligently gives the error message? ch is equal to q. After this, the compiler clearly indicates the default value is missing, right, following this parameter ch. So the compiler, right, suggests as please provide the default value for the subsequent parameters also. So w, right, in this case may be initialized with some default value. Otherwise, you try to write exchange these parameters, float W as the first one, character CH is equal to Q as the second one, right? To avoid the compile time error. Logical conclusion, default parameters should be initialized or defined from right to left direction. If you miss the default parameter, by default, right, the default value has been taken. Even we can set right all parameters, the default values, depending upon the function call, right, whatever is missing, correct setting has been taken from the default initializer. Another thing, where should you set the default initializer? Default initializer should be set in the function prototype statement if it is specified. If not, logically, you would have defined the function before the main. That stage, in the function definition, you can provide the default initializer. This is the logic of default arguments. If you have any queries, right now you can ask.